A stone falls freely under gravity. It covers distances h1, h2 and h3 in the first 5 seconds, the next 5 seconds and the next 5 seconds respectively. What is the relation between h1, h2 and h3? From the question, it is understood that a stone falls freely under gravity and it covers a distance h1, h2 and h3 in consecutive 5-second intervals. We need to find the relationship between h1, h2 and h3. See, the distance covered by a freely falling object in consecutive time intervals can be analyzed using the equation of motion under constant acceleration due to gravity. Using the formula for the distance covered by a freely falling object, h is equal to half gt square, we calculate the distances from the first 5 seconds h1, the next 5 seconds h2 and the following 5 seconds h3. First 5 seconds, that is 0 to 5 seconds, we have h1 is equal to half into 10 into 5 square. Here g is nothing but 10, which is constant, and t here is 5 seconds. So 5 square, which is equal to half 10 into 25, which is equal to 125 meters. In the next 5 seconds, which is 5 to 10 seconds, we have h2 is equal to 1 by 2 10 into 10 square minus 1 by 2 10 into 5 square, which is equal to 1 by 2 into 10 into 100 minus 25, which is 1 by 2 into 10 into 75, which is nothing but 375 meters. For the next 5 seconds, which is from 10 to 15 seconds, we have h3 given by 1 by 2 into 10 into 15 square minus 1 by 2 into 10 into 10 square, which is nothing but 1 by 2 into 10 into 125, which is 625 meters. From these calculated values, we have h1 is equal to 125, h2 is equal to 375 and h3 is equal to 625. Let us compare h2 with h1. h2 is equal to 3h1. Let's compare h2 and h1. See, the value of h2 is 3 times that of h1. Therefore, we can write h1 is equal to h2 by 3. Now let us compare h3 with h1. See, the value of h3 is 5 times as that of h1. Therefore, we can write h1 as h3 by 5. Thus, the relation is h1 is equal to h2 by 3 is equal to h3 by 5, which is option A.